In this video, we're going to identify the greatest common factor for a variety of polynomials and then factor out that greatest common factor. For this first example, we're given the polynomial 12x squared minus 9x. So to start, let's identify the greatest common factor of all the terms in that polynomial. So our terms are 12x squared and negative 9x. So looking at the coefficients between 12 and 9, the greatest common factor is 3. And then with our variable terms, we have x squared in the first term, and in the second term we have x. So the greatest common factor among those is just x. So the greatest common factor of the terms in this polynomial, that greatest common factor is 3x. So that's what we're going to factor out. So 12x squared minus 9x is then equal to 3x times something. Now 3x, if it's a greatest common factor of every term, can be factored out. And so what we're looking at then is we had 12x squared and we're factoring out 3x. So what we're thinking, and we won't often show this step, but this is the thinking that's behind factoring, is that we had 12x squared and we divided out that 3x. And so that's going to leave us then with 4x. So inside here, I have 4x. And if I look at that, 3x times 4x is indeed 12x squared. Now, we had negative 9x, we factored out 3x. So thinking negative 9x over 3x, we can see that that's just going to be negative 3. So inside here, we subtract 3. And so what we have is 12x squared minus 9x equal to 3x times that expression 4x minus 3. If we look to distribute that 3x across to check our answer, we'd have 3x times 4x. And I'll show the check real quick. So we'd have 3x times 4x minus 3 equal to 3x times 4x minus 3x times 3, which would be 12x squared minus 9x, and indeed, that's what we started with. Let's go to our next example. Here, we have a couple different variables going on. So we have a binomial, two terms, and we have 30x cubed y squared minus 45xy to the fifth. So to start, let's look at our greatest common factor. Between 30 and 45, the greatest common factor for the coefficients there is 15. Now we'll look at each variable independently. Between x cubed and x, the greatest common factor is just x, and between y squared and y to the fifth, y squared is common to both. So the greatest common factor of all the terms in this polynomial, that greatest common factor is 15xy squared. So that's what we're going to factor out. So 30x cubed y squared minus 45xy to the fifth is then equal to 15xy squared times something. And now factoring out, we're now writing 15xy squared as a factor. So when we write that out front, we need to figure out what's left from the 30x cubed y squared that we started with and from the negative 45xy to the fifth that we started with. Again, what we're thinking, and I'll only show this for a few, but what we're thinking then is that we started with that 30x cubed y squared and we factored out, so we divided out 15xy squared. And so we should be left with a numerical coefficient of 2. And then we had x cubed, we divided out x, so we have x squared. We had y squared, we divided out y squared, so we don't have a y term still appearing there. So then inside here, we'll have 2x squared, and then with negative 45xy to the fifth, we factored out again 15xy squared. So negative 45, we factored out 15, so we're going to have negative 3 for that numerical constant. And then we had x, we factored it out, so there won't be an x in this term once it's factored. And then y to the fifth over y squared is just y cubed. So inside here, we're going to have 2x squared minus 3y cubed. So when fully factored, we have 15xy squared, and then times the expression 2x squared minus 3y cubed. Our next polynomial here is 6x squared plus 12x minus 20. And as we look at the greatest common factor here, we can see that the terms 6x squared, and then the term 12x, and then the term negative 20, they do not have a variable. There's not a variable in every one of those terms. So we're just going to have a numerical greatest common factor here. And that is what we'll factor out. So looking at 6, 12, and 20, the greatest common factor for those is simply 2. So we will be factoring out 2. And then when we factor 2 out of 6x squared, we're left with 3 for the numerical factor, and x squared, since we didn't factor anything with x out. And then we're adding 12x to the original, so when we factor 2 out, we are then adding 6x, and then we're subtracting 20, so when we factor 2 out, we are now subtracting 10. And again, if I want to check that, I can just check by distributing. So 2 times 3x squared plus the quantity 6x minus 10 will equal, I'll distribute there, and I'll have 6x squared plus 12x minus 20. This last example, we have negative 2x squared plus 6x minus 10. Now, with negative 2x squared, in general when we're factoring, if the leading term has a negative coefficient, we want to factor out at least a negative 1. Here, we have negative 2x squared plus 6x minus 10, so we can factor out the entire negative 2. And as we look at x squared, 6x, and then a constant term, we won't be able to factor a variable out for this one. So our greatest common factor here, we're going to use negative 2. So we'll factor out that negative 2. And when we factor negative 2 out of negative 2x squared, we're just left with x squared. When we factor negative 2 out of 6x, if we're thinking 6x over negative 2, that's going to be equal to negative 3x. So inside here, we're going to have minus 3x. And if we think about distributing, negative 2 times negative 3x is what will give us that positive 6x. Lastly, we had negative 10 as that third term in the original polynomial. So when we factor out a negative 2, we're actually going to have plus 5. And so checking, which we can do real quick, the main thing we want to check here is that we didn't flip any of the signs. So negative 2 times x squared minus 3x plus 5. When we distribute that negative 2 across, we'll get negative 2x squared plus 6x minus 10, which is what we wanted.